All right, here we go. Friday, last actual class that I will teach you this year. Okay, go ahead and get out your homework. So you have what 12 through 12.3, 1 through 16, all. Here we go. So this was all using the quadratic formula. Instructions say give irrational roots in their simplest form. That means reduce and approximate to the nearest tenth. So obviously they want you to take the square root and use a calculator. So here we go. All right, let's see. Number one will be negative 2 comma 5. Negative 2 comma 5. If you put 5 comma negative 2, same answer. All right, number two, I'm always going to say the answer is the smallest one first and the second one if it has two solutions. Number two is negative a half or negative 0.5 and 2. Number three here, I'm losing my place. Oh, there we go. 1/5, right, or 0.2, and comma 2. Number four, negative 1 comma 4. Number five, negative 1 comma 6. Number 6 is negative 7 comma negative 1. Number 7 is 3 plus 2 root 5 or 3 minus 2 root 5. All right, number, what are we on? Lose my place. Oh, number 8, sorry. Number 8, let's see, as a decimal, it would be negative 0.3 comma 3.3. Number, what are we on? Number 9. Number 9 is, let's see, as a decimal, negative 0.7. Well, a smallest one would be negative 7.3, comma, negative 0.7. And they are doing rounding to the nearest tenth there. Number 10, negative 0.2 and 6.2. Number 11, negative 0.7, comma, 0.4. Number 12, negative 0.5 and 4.5. Number 13, negative 0.7 and 1.2. Making me flip pages here a lot. Number 14, negative 1.7, comma 7.7. 2 left. 15 is 0.8, comma 2.2. And the last one, number 16, as a decimal, 0.7, comma 1.8. There you go. All right. As I said, last class of the year, right, that I will teach you something new, 12.4. It's seemingly a very challenging class. It ends up being a very easy class. If you start getting lost, please rewind, listen to it again. Today is a very easy class. Next week's Monday and Wednesday, I'll give you a review for the final. The final will be a multiple choice test. It will cover everything that we've done from January onward, so second semester. And I will review on Monday, Wednesday, and the test, as you can see from the calendar here, the test will be that following Thursday. So a whole week between when I finish the review and when you have to take the test. So be smart about this. Do a little bit of studying each night. Obviously, concentrate on the whatever it is your final is for the next day. So if it's if it's Tuesday night, you should be studying for your Latin final. But, doing about 10 minutes worth of looking over of the math stuff would be a smart thing to do. Use your time wisely. You got plenty of time to get ready for these finals. All right. Here's your homework tonight. So just 12 quick problems. 12 quick problems. These are very quickly done. Very quickly done. Okay, well, let's see how right I am about how easy this is. Okay, you've probably heard about discrimination before. In math, we have something, it's the same word, discriminant, right? And it means, yes, we are going to look at something on the basics of its simple characteristics and make decisions about the thing based upon its visual characteristics. In math, it won't be the visual characteristics, it'll be its numerical characteristics. But we are certainly going to discriminate against some of these equations. All right. So the previous lesson and what this chapter would have led up to at this point, if we had done the entire chapter, is that there are multiple ways of solving quadratic equations or finding the solutions to quadratic equations. Some of them work some of the times, some of them work all of the times. And we have been exploring a method that solves all quadratic equations. It will solve any quadratic equation. And it's a pretty nifty thing. Obviously, it's called the quadratic formula. It's this thing in yellow right here that you did your homework on and that I helped a few of you tutoring. How is this done? Well, first off, you have to have a quadratic equation. Notice in blue there. You have to have a quadratic equation that is of the form ax squared plus bx plus c and set it equal to 0. Well, notice in blue there, it's not in that form. It doesn't say equals 0. It says equal to. So you do a little bit of algebra, just move the 2 to the other side, subtract 2 from both sides, and now it's of the form ax squared plus bx plus c equals 0. For those who say, no, it says minus 4 minus 2, just remember b could be positive or negative, the same thing with c, and a could be positive or negative. Okay, so once you determine what a, b, and c is in this equation, let's see, a is 1, that's the coefficient of x squared, b is negative 4, that's the coefficient of x, and the constant is negative 2. We take those values carefully, methodically, we plug those numbers into the quadratic formula, that thing there in yellow. Oh boy, it's a lot of math, but all it is basic math. We follow order of operations. 2 negatives make a positive, so that will be 4 plus or minus the square root of negative 4 squared is 16, minus 4 times 1 times negative 2. That would be positive 8. 2 times 1 is 2. So we get 16 plus 8, which is 24. Let's see, if we follow the directions from last night or the previous night's homework, it said if you have the square root of a non-perfect square, grab your calculator. The square root of 24 rounded to the nearest tenth is about 4.9. So we get 4 plus or minus 4.9 over 2. That gives us 2 equations. These are approximations, obviously, since we took the square root of 24. So it would be 4 minus 4.9 over 2 or 4 plus 4.9 over 2. And simply do that math. 4 minus 4.9 is negative 0.9. 4 plus 4.9 would be 8.9. Sure, you can grab your calculators. Negative 0.9 divided by 2 is negative 4.45. And 8.9 divided by 2 is 4.45. There you go. And that's what you did on the previous night's homework. Today, we are going to talk about something called the discriminant. And just as when you discriminate against something or someone, right, you are making judgments upon characterizations of that thing. So we are going to make a judgment about this equation based upon one of its characterizations. We are going to call this part right here, which I just put in red, that part, and only that part, we are going to call the discriminant. So what is the discriminant? The discriminant is simply b squared minus 4ac, right? So what does it have to do with anything? Well, we must remember that we can only take the square root of any number that is 0 and greater. We can certainly take the square root of 0, it's 0. We can take the square root of any positive integer, but we cannot take the square root of a negative integer. So we are going to discriminate against certain ones. We are going to determine something based upon the value of b squared minus 4ac. Okay, big picture, you're simply going to look at b squared minus 4ac and discriminate. All right, so the discriminant will predict the number of solutions. How does that work? Well, remember, we're dealing with quadratics. Quadratics are parabolas. Here are 2 parabolas. One of them is a smiley face, one of them is a frowny face. So remember, that's where the A is positive or negative. So when it's we call it concave up. When it opens up, that is where the coefficient of the x squared is a positive value. And when it opens downward, that's when the A value is negative. Now, what I wanted you to notice about these 2 examples right here is notice that they both of these examples, whether it's concave up or concave down, they both cross the x-axis in 2 positions, right? Any parabola that crosses the x-axis in 2 positions, 2 unique positions, we say has 2 solutions. Why? Because remember, we set the quadratic equation equal to 0. What does that mean? That means where the y value is 0. Notice all 4 of those red dots, the y value is 0. That's what we do when we plug our numbers in the quadratic equation, or the quadratic formula, sorry, is that we say that it's equal to 0. In other words, the y value equals 0. Okay, that's fine. But wait a minute. A parabola could also only touch the x-axis in one position. Notice here is a concave up or concave down parabola where it only crosses the x-axis in one spot. Well, if it crosses in one spot, it means it has one solution. Lastly, you could have parabolas that never touch the x-axis. In other words, there's no solution. So what does this mean in our formula? Because remember, the formula tells us where those dots are. It tells us the solutions. Remember, those dots are the solutions to the quadratic equation. Well, in simple terms, it means this. Do you see inside the quadratic formula that plus or minus? That plus or minus is what gives you 2 different solutions. And you're like, well, how could you ever get one or no solution? Well, let's think about this. Okay, well, let me back up. So if the square root of b squared minus 4ac is any number greater than 0, if b squared minus 4ac is any number greater than 0, then you take the square root. The square root of 3, the square root of 13, the square root of 16, right? Then that will give you plus or minus whatever that answer is. That's how you get 2 solutions. When there's one solution, that's when you do b squared minus 4ac, you get 0. The square root of 0 is 0. That's not 2 values. Plus 0 or minus 0 there's no difference. So if b squared minus 4ac is 0, literally equal to 0, then you only get one solution. Lastly, if there are no solutions, if the parabola never touches the x-axis or intercepts it, those are times when you do b squared minus 4ac and you get a negative number. You can't take the square root of a negative number, at least until Algebra 2. And so this is how you get no solutions. So what is the discriminant? Well, first off, the discriminant is b squared minus 4ac. So what does it do? It discriminates and tells you whether there's 2 solutions, 1 solution, or there's no solution. Why should you try to solve the quadratic formula if there are no solutions? It's not going to get you anywhere. This is the power or the usefulness of the discriminant, and this is also why you get taught about the discriminant. All right, some of you probably need to hear that again. So rewind, listen to that again. For the rest of you, let's move on. All right, so the discriminant will tell us whether there's 1 solution, no solution, or 2 solutions. So let's do another one. Here we go. Hey, in blue there is the quadratic equation that we're going to be messing with. Step number 1, just make sure it's of the form of ax squared plus bx plus c equals 0. Okay, in this case it is. In other words, you just got to make sure it says equals 0. If that's the case, then you know what a, b, and c values are. The a value is 2, the b value is -3, and the c value is 5. We take those values and throw them not into the entire quadratic equation, just the discriminant. So b squared minus 4ac. Remember, that's what's underneath the square root symbol. We can take the square root of a positive number. We can take the square root of 0. We cannot take the square root of a negative number. So in yellow there up there, it's just showing you if you get an answer that's greater than 0, 2 solutions. If you get an answer that's equal to 0, 1 solution. And if you get an answer that's negative, in other words, less than 0, no solutions. All right, let's do the math. -3 squared is 9. -4 times 2 times 5 is -40. 9 minus 40 is -31. So the discriminant is -31, and the conclusion is no solution because that's smaller than 0. Okay, let's do another one. Anybody notice a problem? That's right, this one is not in the form of ax squared plus bx plus c equals 0. So just force it to. Subtract 7 from both sides, right? And now it is of the form of ax squared plus bx plus c equals 0. Once again, I don't care that it says ax squared plus bx plus c. B and c are just the values. So in this case, b is -5, c is -7, and a is 6. Throw those values into the discriminant, b squared minus 4ac, and then do the math. -5 squared is 25. -4 times 6 times -7 is a very large but positive number. Okay. It turns out that the discriminant is 193. Well, 193 is positive, therefore there are two solutions. Remember, if you get a positive answer to the discriminant, two solutions. If you get 0, one solution. And if you get smaller than 0, I'm not sure why that says, oh, I see why. If you get any value that's negative for the discriminant, then there is no solutions. You feel confident? Yeah, I mean, literally, this is all we're doing. Okay, so we're just going to do 3 examples all by yourself. Notice the middle one there is not of the form ax squared plus bx plus c equals 0, so make it first, and then get to the discriminant, and then tell me how many solutions, and then answer that, and this is question number 2 on the Google Forms. How'd you do? Okay, I'm going to skip the plug-in numbers in. I'm just going to tell you the discriminant of the top one there. The discriminant is negative 28. That's a negative number. If you ever get a negative number for the discriminant, no solutions. For the middle one, after you move the 10 to the other side, so you should have messed with x squared minus 7x minus 10 equals 0. So a is 1, b is negative 7, and c is negative 10. You will get a very large positive number, 89, the 2 solutions. Notice I don't even really care what the actual number is for the discriminant. I only care whether it's negative, positive, or 0. All right, who wants to tell me the last answer? What's the old math teacher trick here? The first one's negative, the second one's positive, and the last one, well, it must be the third option there. So let's see. It is true. A was 1, B was 16, and C was 64. And when you do that math, you get 0 as your discriminant, therefore 1 solution. Okay? So, I told you today was pretty easy. For those of you that are still a little bit shaky on this, please watch it again because it truly is easy. All you're doing is b squared minus 4ac and seeing if you get a positive, negative, or 0 as your answer. Your final answer, however, is the interpretation or the discrimination using that one factor to determine whether the thing has 1, 0, or 2 solutions. Make sense? I hope so. Okay. Hey, that was the end of a pretty darn good year. We did a lot of good work here. So we did not cover a couple of things. You'll be fine into Algebra 2 when we get there. Algebra 2, at least a third of it is reteaching some Algebra 1 concepts, and then the rest is new stuff. You'll be fine for the things that we did not cover. I also have the ability next year in geometry to recover some things just to reinforce them so that when you take your first PSAT test, right, your practice SAT test, that you'll do very well on it. I'm confident that most of you guys will do well. So we had a great year. Obviously, we're still going to have 2 review classes, so I'm not saying goodbye right now. But just wrap it up for the entire year. It was a pleasure teaching you guys. You're definitely one of my favorite classes, and do your homework.